In this lecture, we'll do two examples. One is that right here, based on this graph, we want to determine the form of a function. The second one is given a graph, we want to find the form of another function. Let's look at the first one. Based on the graph, this graph, we want to find out the form of the equation. Basically, we want to find the equation. It looks a little bit scary at the beginning, but actually it is not. You know, here from 0 to 2 pi, it has two periods. You see, those two are identical. Okay? And then the period will be from 0 to pi is one period. So you can see the period of function is pi. So you may write it down. Then which function has period pi? That's either tangent or cotangent. But you know, tangent, the typical interval is from negative pi over 2 to the positive pi over 2. Cotangent is from 0 to pi. So then this one might look like a cotangent. Okay? Alright. Then you may think about cotangent. Cotangent, previously we know, has this typical picture and typical values here. That's for cotangent. Okay? When x equals pi over 4, we know cotangent pi over 4 is 1. So basically, you see, this is the point. It goes down. Now, but here is different. It goes up. When x equals, here is pi over 2. Here is pi over 4. Because that's in the middle. When x equals pi over 4 is negative 2. But again, you know, for cotangent, when x equals pi over 4 is 1. So it's on the above x-axis. And here x equals pi over 4 is negative 2. That's what I wrote. Oh, that's not the problem. It's because of what? It's because cotangent previously goes like that. And this one, it goes from, it increase, cotangent decrease. This one is increase. So that's because of what? Because the function is flipped. Okay? Yeah, if it was like that, going down, you flip it based on the x-axis, then it's going up. So if it's flipped, you know it's a negative. And then, when x equals pi over 4, it was 1, now it's negative 2, so you know x equals pi over 4 equals negative 2. Okay? So basically, the graph is elongated 2 units. So multiplied by 2. Then the graph is flipped and stretched with 2 units from the graph of y equals cotangent x. So then you know, if I put negative 2 in front of cotangent x, it's going to make it. So then the function will be that. So it's not hard. Now, look at this one. This one is from negative pi over 6 to positive pi over 6. Okay? And then we know this will complete from this point to this point. It will complete one period. So how long is this one? Because this is one period. And of course, it's the distance between this point and this point. And you use pi over 6, subtract negative pi over 6. You then have what? Pi over 6 plus pi over 6. Because here is negative. And then you have a 2 pi over 6, cancel 2, pi over 3. So from this point to this point, the distance is pi over 3, and then that's one period. So the period is pi over 3. Okay? Now, if it's pi over 3, you know, the cotangent, the period is pi. And then if you pi divided by 3, then you probably agree it will be what? It will be something like this. Tangent 3x, because tangent 3x has period pi divided by 3. So you might think, tangent 3x might be involved. And that's actually correct. But why do we actually choose tangent, not cotangent? Again, tangent, the typical value, typical period is from negative pi over 2 to the positive pi over 2, and it goes through origin or it goes across y-axis. That's why we think about tangent, not cotangent. Cotangent does not go through y-axis, okay? Tangent does. So then we may think about tangent. Then you know the standard tangent goes through origin. Okay, if you don't remember, you can either do the what? Tangent there. You see, y-axis, it goes through origin. But here it goes through what? Negative 2. That's basically the graph is shifted from origin to negative 2, 2 units down. And then is actually each value subtracted by negative 2. So then you do what? 2 units down without shifting, then you know it basically 1x equals pi over 12. The value should be 2 units up, should be here. It was here, 2 units up is here, it was here, 2 units up, it will be here. So then you know, desired function might be this one. Okay, y equals negative 2 plus tangent 3x. Alright, you may try that. You may try a typical value. You plug in what? You plug in pi over 12 here. And then 3 times pi over 12 is pi over 4. And then for tangent, pi over 4, you know, is 1. And then plus negative 2 is negative 1. You see, here is negative 1. This point, right here. So pi over 12, negative 1 is on the graph. That's correct, algebraically. Okay, so this one looks hard, it's actually not. Okay, I'll see you next time.